So, good morning, good afternoon, good evening, wherever you are from. So, my name is Deven Yadav. So, I'll be covering some easy SQL Server performance tuning techniques, and we'll be having like six demos as well as small explanation on the slide. So, I'll be running through most of the demos mostly and that's what our plan is. So to begin with, let me introduce myself. I'm Deven Yadav. I have like 22 years of SQL Server. I had been in SQL Server since 6.5 version, and I'm working with Health Plan in California, Bakersfield. So currently, I'm mostly on uh, the supervisor role, but throughout my journey, I had been working with SQL Server and seen it growing like from right from the very starting version. So I'm very much passionate on performance tuning, database development, SSIS development, and kind of mentoring with my team. So as I said, I'm from the Bakersfield, so the city is always felt home for me. And on a personal note, I'm happily married with my wonderful wife for last 20 years. I have two sons who have been in high school currently, and they have been quite busy with them since they are in their teenage years. So in my free time, I explore my interest in culinary cooking. So I try cooking for my family, for myself, and kind of inspire my kids to cook so that they can be independent in doing that. And I enjoy like connecting with nature throughout doing camping, hiking. So I have a group where we kind of go every month, small hike or a camp. So which kind of quite uh, refreshing for my after the kind of work which we do so far. So so let's dive in with my first demo, which uh, I want to show you is okay. So my first demo is on uh, kind of a sargeability issues which we face. Usually, sargeability is not an kind of a English term. It's a kind of a word which says search argument, uh, uh, argumentable. So it refers to the query's ability to efficiently use the indexes. So usually, as a DBAs or developers, we have seen this, and for the new developers DBA, they kind of uh, write the query not in the efficient way. So so in my demo, let me use AdventureWorks. I'll be creating this index. Okay, so I'll put statistics time on. And so over here, we can see this query. Uh, this query is a simple select query from the cell sorted header with joining with the detail table. So you can see the problem with the query is the where clause, which has the uh, some mathematics done on the left hand side, which kind of we are trying to convert the date into the varchar, and then we are comparing with the date what we are providing. So if I run this query with my execution plan on, I can see it's returning result, but there is an scan, index scan on the execution plan. And this uh, this is even though we have an index just created on the modified date, it's kind of scanning on the column which we created the index. So this is the classic example of non-sargeability. So to fix this issue, we have to make uh, kind of a sargeable query. So basically, I change the query without changing its actual logic. So it's still selecting filtering with the modified date, but it's having like modified date less than or equal to the date and the greater than equal to the date. So it's still the same logic without changing the logic. If I run this query, it returns the records, and you can see the index seek is on the detail table. So this is what I mean to say is like uh, if there is an inefficient query written in the by developers, usually this happens while we are reviewing the legacy code. So many developers, DBAs, or also on the reports, I have seen that people don't take care of the writing the code properly. So this is what we have. And to specify this more detail, like in current SQL Server 2022, we have like an extended event which can detect the entire patterns, anti-SQL Server patterns, which detects like a non-sargeable expression. So if we create an extended event on our instance, it can detect this kind of an issues, and we will be quite we can modify these queries which are running in this kind of pattern. So that's it, and I'll drop this index. Okay. Okay, so to summarize, the sargeability is like foundation of efficient query. So the problem is like function on index columns prevents index seeks. Common culprits we see it's convert, cast, or date functions. So solution I would suggest is like rewrite expressions uh, to preserve the original column format. And result is like dramatic reduction of IO and CPU usage. So that is the result. So let's go to the next example. I have like also many times customer says or the peer DBA says like I have a queries but index seek is not happening. So uh, so current demo we have like a simple query which is running on the percent call table. So it's kind of reading the first name from the percent table. So if I run this, the execution plan on, it returns some records, but you can see there is a index scan on this percent. But if I hover around, so you can see the object, the index which was created on the percent has the uh, index on the multi columns, which is last name, first name, and middle name. So since we are querying on the first name, which is the middle of the index, it's there are scans on this query. So the order of index SQL Server optimizer basically reads from left to right, which is last name, first name, and middle name. So since we are reading directly the first name without going to the last name, there is an complete scan of all the records to check the first name, which is Ken. So it will try to scan entire all records, and even though we have this index. So to resolve this issue is like we can have this kind of query where we'll have a first name and last name. So if I run this query, I can see there is an index seek since we have a last name already included in this example. So that way, last name and first name is the two columns are already uh, uh, part of the index, and that makes the index seek, and which is kind of uh, which is what the result what we want. And also if uh, if we try to uh, query only the last name with percentage on the last, this will also do the index seek. I have to use like operator. Okay, so this will also, you will see it will do the index seek since it is getting all the records with Sanchez and the percentage part, which is the on the last. So this is still chargeable, but if I try to do it in the different way, like percentage on the ahead, it will kind of do the scan. You can see it is doing the scan. So like conclusion is like we should not use the percentage sign ahead of the on the it should be on the always last of the string. That way it will not do the scan on the index. So yeah, that's what this demo is. So to summarize, so for multi-column index, which is very complex, I would say at least one column is required. And if we are filtering on the leftmost column, it gives the index seek. And if uh, only one column is filtered, then it is effective if one column is filtered. And string patterns is like the wildcard should uh, not be the leading wildcards. It will prevents the index seek. So the wildcard should be on the end of the string. That will makes the seek proper seek. And that brings us to the third demo, which is the implicit conversion. So implicit conversion is very common in the legacy system, also in the newer system queries which we have designed. So implicit function basically happens when there is a mismatch in the uh, where clause. So as you see, let me run this. And this can be quite performance impacting since it's trying to convert the string variable into the, if you see, this is the uh, column is the varchar column, and the string which is we are querying is n varchar. And if I run this query with execution plan on, you can see it's there is an select clause which is having uh, warning sign on it. And if I hover this, it says that there is an convert implicit and varchar so to seek plan. So it's trying to convert, and then it's deteriorating the performance. So to fix this issue, we can just remove this. It will become a varchar. And if I run this and go to the execution plan, the select uh, the warning sign from on the select operator is gone, and it's performing well. But if you see just for the one query, we won't see there is a difference. So if we try to run this query for a couple of times, it may give us the more impact on why the implicit conversion is impacting on the performance of the SQL Server. So for example, this query, if I'm running for 100 times, like there are 100 users which are trying to reach out and run this query, it takes too much of the CPU. And you can see I will run this. It runs for 100 time and it takes around 6 to 7 seconds. Okay, it took 21 seconds. So if we see the without uh, the conversion, should be much faster. It takes 13 seconds. So it does improves the performance since the conversion uh, is is not been done, and you can see the execution plan without the conversion. So bottom line is like we should have we should review our parameters which we are passing in the where clause, and both should match. If the column is varchar, we should have kind of a varchar on the other side. And to have this resolve this issue, we can use the explicit function, which is over here. So in this, you can see I am not converting the anything on the column side. I'm converting the variable before I'm comparing with the column. So if I run this 100 times, it should be take the same amount, which Okay, 14 seconds. So the solution would be like we should have like pass our variables in the explicit conversion format. That way, SQL Server doesn't has to convert, and the performance is improved with this kind of design. So that brings to the so to summarize. The implicit conversion is like a silent performance killer. It kind of there is a type mismatch between and varchar to varchar, which forces the implicit conversion. So conversion often prevent index usage completely. It completely bypass the indexes. It also increase the CPU load when we are using the large tables, or there is an too many transaction happening at the same time. So solution is to use the matching data types or kind of explicit convert function on the non-index side. That way we can solve this issue. And that brings up to the my demo number 4, which is dynamic SQL plan cache. So this demo is basically is on the uh, uh, query, which is we are in this scenario we have a query which is a dynamic query, and we are passing a variable from in the while loop. And so whenever the query is getting a new parameter variable in the while loop, it creates a new uh, it creates the new execution plan. So if there are 100 parameters passed, so there are 100 execution plan. So uh, on this basically makes the uh, loading of your plan cache, since there are many multiple uh, uh, execution plan in your plan cache, and which impacts your memory and CPU utilization, and it creates unnecessary load on the SQL Server instance. So to demo this, I will pick up this my helper queries, and so currently if I run this, it says there are 48 plans currently cached, and 12,480 bytes in the cache plan. So it's consuming this amount of memory. So for the demo purpose, I will be clearing the cache so that we'll have the correct. So let me check how it looks now. So now it's only 9 cache plans with 368 bytes. So if I run this, it runs like for 289 rows. And if I go back over here and I check, yeah, so you can see there are 30 different plans, and the cache size has increased to 8,000. So this is what is called this plan cache bloating. And so for uh, the solution for this is to write the query in the different way. So if I want to see which are the unique plans in the query. In the instance, I will be using this query right now to see how many. So it says like a two different plans currently present in the cache. So the optimized version for this is uh, I'll be in the above query. Instead of passing the parameters in the as a variable, we are passing it in the different manner. Like I have defined a variable called organization level, and that variable I'm setting it in the parameter definition, and then the the query has been executed by passing the SQL string, which is the query, and the parameter definition, uh, which is the organization tiny, which you can pass through the organization level as a variable through the while count, and that way, if we have more than one variable, we can still do a comma over here and add more variables. So that way, it will have like reuse the current plan, and it will be like explicit parameterization rather than the uh, parameterization what we have. So if I run this, let me. Okay, if I run this, it ran, and if we see plans, there are 11 plans, and it has very less amount of memory which has been consumed. So if I check the helper query over here, it will show how many plans we have. So it still says 2 plans, but the amount of memory is decreased by using that. So that gives the less amount of pressure on the SQL server while using this method. So this method is quite some. It might be quite new for some of the DBAs since it's uh, not normal to use this kind of design in the query. So for the dynamic query, I would recommend we should use the optimized version while not by passing the parameter, by defining the variables and passing it outside through the parameter definition. So to summarize, so what we have seen is the plan cache bloating is that dynamic SQL Server has embedded values which create unique plans with identical queries. And if we are not using the explicit conversion, it kinds of memories. There are too many plans been created, which creates the bloating in the plan cache and which waste the memory. So the parameterization solution is like use sp underscore execute SQL with the defined parameters, so which will improve the query performance and its consistency. So the next demo what I have is so next thing I would say there is an bookmark lookup impacts. So I had created like a two big tables in the adventure works using like Adam mechanic technique. So let's go with the demo. You can set statistics on, and over here it's a select query from this big product table, and which is cross applying with the transaction table, checking the product ID from this table, and there is a where condition between, it will select this kind of records. So if I check and if I run this, okay, so it completes within 3 seconds, and execution plan, you can see there is an index. It's running fine. So in the real scenarios, in the transaction table, some of our developer has something change to the transaction table. They decide to add a customer ID since there was a request from a business. So let's add this customer ID. So after adding this customer ID, I'll drop the temp table. If I run the above query, it will, let's see how it performs. So earlier it took like 7 to 8 seconds, but now after adding this column, it looks like query is running and taking more time than the actual time. So it's taking more 10 seconds than the earlier. So some like we would be thinking what happened, like it was running very accurately, very fine before the change, and how come the change is impacting the query performance. So why it is running so slow. So if you see the execution plan over here, you can see there is an highest cost in the execution plan is the key lookup. So if I hover around, okay, so the key lookup table is kind of showing there is a customer ID part of the query. So earlier there was no customer ID, but now since we introduced the customer ID, it is kind of going into each and every record and checking the customer ID also as a part, even though it was not there. So it is kind of scanning for the customer ID. So, and it is giving us like an hint to create the missing index. So if I look into this missing index, it says that customer ID requires to be added. This new index should be required. But if I look into the transaction table and check this, there is already index on that table. So you can see the index is already there on the transaction table on product ID and transaction date. And the new index, it's trying to we are creating the new index on the product ID, which is already part of this existing index. And uh, the include column, which is the quantity and the actual cost, is also part of the existing index. So if we try to create a missing index blindly with the recommendation from the SQL server, it will create like an duplicate or like covering index, which is conflicting with the existing part, and that is not. I would not recommend doing that way, because you will have too many index on the table. But this index is specifically for the query which we are showing. So the indexes should not be created based on the query requirements. It should be kind of a generalized indexes we should have. That way, uh, it can be utilized with multiple queries. So, uh, so uh, to resolve this is like you can create a missing index, which I would say no, add a column to the existing index, which as a covering we can add over here the customer ID, and then also it can fix. But we should not do that also. The issue is over here is like the select star, which has been utilized in the top over here. That is the issue which is creating this main problem. So you can see this query, I have specified the column names when we are querying to the uh, query, which, and it is not using the customer ID in this. So this is the only columns which we require. So if I run this query, it without customer ID, so I have to drop. So if I run this, it performs as it very fast. So even though we have the customer ID column in that, so uh, so conclusion is like we should use the best practices while designing the query. We should try to avoid using star, specify the column names whenever we are wherever we it's possible to provide the column names. That way we are restricting the query to use only those column, and any new columns or anything change in the schema won't impact the existing query performance. So to conclude is, so uh, how bookmark lookup performance impact. So index lacks the, for the non-covering index lacks columns needed by the query. So in the key lookup is required, engine must require the missing columns on the base table. So for solution is like include all required column in the index definition, or that will help us. So that brings up to the last demo. What I have, it's called parameter sniffing. So parameter sniffing is very common issues what we face, and in this demo I'll show you how parameter sniffing impacts the performance. So I'm using AdventureWorks, and let's create a store procedure simple where I'm checking a ship date between start date and end date from the sales order table. So this procedure is created, and let's create a index on the ship date for the better performance. And let's so for the simplicity of this demo, I will again clear the proc cache. That way we'll see the performance. So if I run this first query with uh, dates, which is like almost a couple of years used data, so it let's enable the execution plan and run this. So if I run this, it returns good amount of data. And if I check the execution plan, there is an scan on the index index column is scanning for this. And same store procedure, but I will change the input parameters as like couple of days instead of months. You'll see the difference. So if I uh, but before running the second query, let's change remove the cache, and if I run the second query, you can see there is a seek. So the first query is scan and second query is seek, even though it's using the same stored procedure but different variables. So this is kind of example of an the parameter sniffing. And uh, so in real world, it won't happen. We don't clear the proc cache. The query is run directly. So uh, if I run this, let me clear this first. And if I run the both query without clearing the proc cache, let's see what it does. So in this, the first query, it is scanning, and the second query is also scanning. So earlier, when we cleared the proc cache, it is kind of it was seeking. Now the second query is also scanning. And what if we do the reverse order? Like if we run the second query first and the first, so and this proc cache, you can see the second query is taking seek. And if I run now first query, it is also giving a seek. So, so conclusion, what I wanted to show is that in the parameter sniffing, it whatever plan is been planned cached first, like if it is a scan plan or a seek plan, that plan is reused again and again, and it doesn't create takes the new plan. So even though the in the example which I showed, the second query was using the seek plan, but if the first query is already in scan, it all follows that, and the vice versa. So this is kind of a parameter sniffing. Uh, and to resolve this, there are a couple of options. What we have is kind of we can recompile the query. We can create a query with recompile, or uh, if we have this recompile option also in the statement level. And the third option is like if we provide an query hints, which optimize for this. So the best out of three, I would select the second option. So let's apply this. create a stored procedure with compile. So now if I run this query without, I am not clearing the proc cache, I'm running as it is. So this query will return scan, and if I run this again, the second query, it is returning seek. So it's not following the scan pattern what we had. And if I run again the first query, it will still go into scan since it is recompiling. Yeah. So that way, this is the like we have to trade off some of the uh, CPU and the memory usage, because every time query is recompiling, it kind of has an overhead on that. But we have to trade off with kind of with the some of the query design with the resources. So you have to take the decision which kind of trade-off you have to do. So that's what the we can resolve the parameter sniffing issue. So you can see in the plans are cached and reused for the subsequent execution, and optimization can backfire the data distribution. So if the plan is optimized for one parameter, may perform poorly for others. For example, like plan is used for New York may not be efficient for Wyoming. So this creates like inconsistent performance patterns that are difficult to diagnose. So solution, what I would say is like option recompile for the parameter sensitive query, consider like guide for critical queries, and in extreme cases implement dynamic SQL with hints. So that is what would say. And the last slide, which I would give some recommendation, like we should always do the performance testing. Like if we can't have the production size data set, uh, we should do some testing on the small data set, which may hide the performance issue. So if you can create some data set, large data set, like with synthetic data, uh, there are many tools available like Python, or you can use C# to create synthetic data. Uh, and with that big data set, we can kind of do the performance testing very well. And we should always monitor kind of our production instances to find out the irregularity of the execution plan, and which we have to kind of uh, modify or optimize that plan. And for the database development, I would say there should be a proper code review, and which can check on the searchable predicaments and on all the queries, which will verify the data type inconsistency between joins and comparison. And last and not the most important part, I would say, is the documentation. So we have to document the reasoning behind uh, index design and considering the database schemas. So yeah, that brings us to the end of my discussion. I can take on the questions or anything from